When we're ready to add aggregations to our cube, we come to the Aggregations tab of our Cube Designer. There we'll see each of our measure groups displayed. Here I have reseller sales and internet sales. We create separate aggregation designs for each measure group because of the way that Analysis Services stores the information in the file system. Let's start with reseller sales. We're going to design aggregations by using a wizard that's available here from the first button on the toolbar. The first page asks us to review aggregation usage. Here we see each of our dimensions and the various attributes that are available within those dimensions, including our role-playing dimensions. Notice that everything is set to default. That allows Analysis Services to decide on a case-by-case basis whether or not to include a particular attribute in the aggregation design process. Unless you have a very good understanding of how aggregations work, it's probably best just to leave the default setting. But if you know, for example, that users are always asking for information by order date year, then you can come over to the full column and change the calendar date year to full. Now we get a warning that tells us that the full aggregation usage setting should be avoided whenever an attribute has a lot of members in it. If we had thousands and thousands of calendar years, then requiring Analysis Services to store aggregations for those thousands and thousands of members would not be a good idea. But we only have a few years in our sample database, so using the full option here will not cause a problem. On the other hand, if we know that users never ask for information for a particular combination, we can set the value to none. And this just speeds up the aggregation design process because it eliminates an attribute from the many possibilities that Analysis Services has to consider. And then unrestricted allows Analysis Services to decide, based on various criteria, whether or not to include an attribute for consideration in the design. Let's go ahead and leave calendar year as full so that we can see what actually happens. We'll click Next to continue. And now we need to provide object counts. The Aggregation Design Wizard needs to know the relative size difference between various attributes to determine whether something is a viable candidate for aggregation. So the smaller the number of values, the better. An easy way to get these counts in place is just to use the Count button, as long as the data that we've specified in the data source view is representative of the data that we're actually going to have in production. So we see the number of records in our fact table, and then we see for each attribute the distinct count of members for each of those attributes. So when the number is relatively low compared to the fact table, Analysis Services is very likely to consider that particular attribute as an aggregation candidate. Now, if we know that our actual data is going to have larger values than what we see here, we can always come in and change the values to something else. It's a good idea to plan for growth and put in the estimated amounts so that the aggregation design is closer to what you'll need over time. When we're ready to continue, we click Next. And here's where we set aggregation options. The first option we have is to have Analysis Services allocate a certain amount of space to aggregation storage. In this case, we can restrict the storage to 100 megabytes. This option is not really used much anymore. On the other hand, we have an option here to design aggregations until I click Stop. The Aggregation Design Wizard will spend a lot of time considering all kinds of possibilities until I click the Stop button. However, there's really no way for me to know which aggregations it has already designed and which ones should still be considered, so that's not really a good option for practical purposes. Then we have this option, Do Not Design Aggregations, which doesn't make sense if we opened up the wizard for the express purpose of designing aggregations. So that leaves us with performance gain reaches some percentage. The default is 30%, which is a good place to start. And what happens with this option is that Analysis Services looks at what query performance will be like if we have no aggregations designed and compares it to the query performance that it expects when we do have aggregations available. And it compares the time required to respond to each of those queries, and it's looking for a certain performance increase. So we'll use this option, and we start with 30%. We'll click Start. And now the algorithm will execute and show us in graphical form the progress that it's making. Here we see in this chart, along the horizontal axis is the amount of space that's required to store aggregations, and then the vertical axis shows us the performance improvement gained by adding aggregations. So we see that as we store more aggregations, the performance increases, and then it stops when we get to 30%. It will take approximately 191 kilobytes to store 19 aggregations, which is not a lot of space, but we get our desired performance increase. So we click Next, and then on the final page of the wizard, we give this a name. I'll call this Aggregation Design 30, and then we can deploy and process now, or we can save the aggregations and process them later. So processing just reads through our fact table records and calculates values according to the aggregation design. Let's save the aggregation so we can just look at the design at this point. We'll finish the wizard,